class, it's Miss Thibodeau.
Just kidding. It's Mr. Athide coming in with some graphing quadratic functions with technology. You're learning with me today. What a treat. Now, you've done the graphing part of this manually before. That's all 6.3 stuff, getting a table of values. Here, we are using Desmos to help us graph these quadratic functions and then perform these same analyses as you've previously done. You'd be using Desmos test mode, obviously, since that's the mode you'd be using on a test. I'm just going to pull up not the test mode as my side window, but functionality-wise, same. Whoop. So if you want to graph this quadratic function, go into slot number 1 and type it in exactly as it is written. We say y equals x squared minus 2x minus 3. And there is that graph beautifully drawn for us. And we can transcribe it onto this blank grid here where we want to graph it. Now, when we do that, we're going to want to make sure we find these points with some exactitude. Desmos handily provides us with the vertex, a nice little dot we can click on. It's at the point 1, -4. So great, we can fill that in. When we do that, take a look at the scale here. Note there's a 1 for each grid line for the y-axis, but the 1 for the x-axis grid lines, it's on the second tick mark. So just be careful when you're counting that. For us to plot this vertex at 1, -4, make sure you're actually using the x value of 1 and then counting down to get that -4. But we can plunk that in real great with a bright blue color. We'll want to plot all the values we can find. Desmos does have some of them handily ready for us. Any of the intercepts we'll be able to just click and pinpoint. That's awesome possum. But anything else might not necessarily be the easiest thing to see. So if we want to know what happens when x is 2 or when x is 3 or when x is 4, Desmos can do that for us. What I can do is just type in x equals 2. And now I see a little dot to click on where my actual quadratic function and this x equals 2 line happen to intersect. Clicking on it, it's the point 2, -3. So I can take that point 2, -3 and now plot it on my grid here. Again, being very careful when I'm counting this. If 2 grid lines is 1 for x, then I need another 2 grid lines to reach 2. But going to -3. So that's where I'm going to be plotting my point. I can similarly get next points. Sure, it's one that Desmos gives to us quite nicely, but if I want to follow this same method, I can let x equal 3, and again, a vertical line connects to that parabola, and it's at the point 3, 0. So I can plot that on my grid as well. We can continue with this. We can say see what happens when x is 4, and that intersection is at the point 4, 5. So that gets plotted in there as well. We could try seeing what happens when x is 5. Looks like that's way up at a y value of 12, and this grid does not quite get us that high. That looks more like 10. So we'll not plot that one. We can go the other way as well. We've already figured out what happens when x equals 1. That was the vertex nicely provided to us. Thanks, vertex. But continuing leftward, we can check what happens when x is 0. And that's the y value of -3. We might have anticipated that because we know parabolas have symmetry. It should be the same y value as on the other side. But hey, we got it manually this way. It gave us the same value. We know we've done something correct, so we fill that in. And we continue along. What happens when x is -1? Well, that's a y value of 0. And we go further. What happens when x equals -2? That's a y value of 5. And again, we know that the next y value is going to be way too high for us to plot, so that's all we can get with it. You can also very nicely see the axis of symmetry in here, if you want. Just look at the specific vertical line that happens to cut through that vertex. And there it is. And handily, we've even got its equation. It's just straight up, x equals 1. That is that equation of the axis of symmetry. If you want, you could even just fill that in right over here where you need the equation of the axis of symmetry. Granted, you already knew it's just the x value at the vertex, but hey, we see it in Desmos as well. It's creating that mirror line. We're not done graphing this. There's dots, super, but we can see in Desmos, this graph is more than just dots. It's a smooth curve. This whole thing is connected. There's points here where x is 1.44, or here where x is 3.18. All of that gets filled in, so we do have to play connect the dots. When you do so, please, for the love of graphs, don't just try and do it in one swoop. Wow, that was terrible. Even if you go kind of carefully, you might not get a smooth arcing shape. Like, look at all these wobbles. I could do way better than that. So go carefully. I personally recommend using kind of a sketchy line method where I just kind of draw it little bits at a time. I can slowly curve through all my points, flattening out at the vertex, of course, and then continuing on. So I'm not doing it in one swoop. I'm going to be super inaccurate if I try doing this in one swoop. Doing this with these sketchy lines, or at least doing it with some amount of care, makes it actually look like a parabola. And let's see if we can get this one. Oh, there we go. Equally as wide. Just playing around with the zoom on Desmos, look, we can see those are same. From here, now that we've got the visual aid for us, we can pretty directly get all this information. Number of turning points for a quadratic function, it's 1. The vertex, we already found it, but reminder, there it is. At the lowest point, it's 1, -4. Those are coordinates. Don't forget the brackets. The direction of opening, is this going to hold soup or is this going to dump it out? It's holding the soup up. Does it have a maximum or a minimum? Let me just get rid of this axis of symmetry. There we go. Does it have a lowest point or a highest point? Well, if somebody's riding this ride, they're pretty clearly going to reach a low before going all the way up. So this thing has a minimum. And more specifically, the minimum value of y is -4. Domain, we can see that this in Desmos as well, that it goes on forever, ever, all the way to left, all the way right. It doesn't stop doing that. Even if we squish this down real good, squish, we can still zoom out and see it's still going on forever, ever. So domain, infinite in both directions. We could phrase that as saying x is any real number. Oh, my R could be better. There we go. Or in interval notation, left to right, leftmost value, we don't reach 1. We go to -infinity. Rightmost value, we don't reach 1. It goes to +infinity. For the range, we can also phrase that in interval notation, lowest y value to highest y value. We know there's a lowest. We called it a minimum. That was at -4. And we go up onward to the sky to infinity. Round bracket for the infinity, of course, since we can't actually reach that. It's not a number. Square bracket for the -4. Because we do actually reach that point. I can tap on it right in the graph. And in more of a set notation, that's all of the y's such that we are greater than or equal to -4, but we are still talking about real numbers. In terms of the end behavior, where do we go? Where do we start from? On the very left side? Where do we end up on the very right side? We can see left, we're finishing off in the top side, so quadrant 2. And on the right, we're also on the top side. That's in quadrant 1. Y-intercepts. There's one of them. We only hit the y-axis once. That's at the point 0, -3. So there's one, intercept. And that is, again, the point 0, -3. And for the x-intercepts, where do we hit the x-axis? We can see those. We can tap on them as well. We get their coordinates. There are 2 such intercepts. One of those is at the point -1, 0. And the other one is at the point 3, 0. If you have any questions, that's awesome. It's always great to be curious, but I can't answer them through video. What you should do at this point is try out the other 2 examples here. I'd go through them, but process-wise, it's exact same as this. So try them out, make sure you can do them, and then check the answer key online just to make sure you got everything A-okay. And if you did, then make sure somebody gives you a high five. If you didn't, then personally, I'd say don't erase your work, but put a circle around it and say, hey, pay attention to this. Here's the oopsie I made, and here's how I'm going to fix it for future. It'd be great for review purposes. Of course, once you've done those examples, there's a great set of homework, which could just be class time work or school work if you finish it in a good amount of time. That's it. That's all for me. It's been most lovely.